Okay. So we want to thank you for coming and listening to our presentation today, and we'd like to send a special thanks out to our professor, Dr. Hedengren, for posing with us in our selfie in the lab. We're experts in our field. We have spent some time working with Dr. Hedengren and his graduate student, Mostafa, on our project. And some of the concerns with our project are some of the government regulations with CO2 emissions today. We are trying to minimize those CO2 emissions by utilizing wind power. And our objective is to do that using wind power and an energy storage while avoiding brownouts or potential blackouts at all in the power grid. And with that, we will move forward to the background. So our energy demand fluctuates throughout the day, kind of in a sinusoidal pattern with minor fluctuations throughout the day that we really can't control. And the sinusoidal pattern, we go up from 1200 during the peak hours of the day and 600 down at night, and with an average of about 900. So what we've done is we've integrated a threefold system that has wind energy, coal, and battery to reduce those CO2 emissions. Now, as you see here, our CO2 emits quite a bit of smoke into the air based on our picture, and the wind does not produce any CO2 emissions once it's already built. And we have this graph right here represents those fluctuations that you get. That's an actual wind pattern that data that we got from California, and as you see, it is very variable. We cannot control that, so we try to create a process that will use that wind power to our advantage, and therefore reducing our coal emissions. And we did that by storing energy, and we called it a battery, but it's just basic energy storage. And ultimately, the goal is to not have any brownouts.
Yeah, go for it. So here you can kind of see how the system's set up on our Simulink model. You have the demand right there with the base load of 900 and that sinusoidal wave where it varies from night to day. And then also some random disturbances. You never know exactly what's going to happen with energy demand. And so all those sum up make the total demand. And then going into the supply of energy, we have the wind energy, the coal, and then also the battery. And so you can see right there, it's got the wind energy is pulling from the actual data that was collected in California, and so that adds into there. Then the coal energy and the battery. And the battery acts very, very quickly because it's just much faster response to a very small town. And we have the set point you can see for both the battery and the coal. They're set above zero because we want to ensure there's always a sufficient amount of energy. We never want to drop below zero. So you can see it has the excess energy where it's just the energy supplied minus the demand that we have. But we also integrated the battery term, so as it's storing energy, we integrate that to see what the total charge in that battery is. And so then that then connects to another set point. Once the battery has 400 megawatt hours stored up, that starts controlling the set point of the coal. And so it'll lower the set point of the coal down a little bit, which will force the battery to pump some of its energy out and lose that charge. And then once it loses some of that charge, it'll increase the set point of the coal again, so the battery can start storing it. And so that way the batteries will be able to be used most effectively. Store the energy when we have excess from the variations like the wind, and then give it off when we don't have enough energy, basically in a night and day cycle. And so you can see how the battery's working right there, where it's storing the energy sometimes when it's below zero, and then it's giving off that energy when that value is positive in that graph right there.
So just a little bit about the final results of this project. That top graph shows the excess energy curve that we generated from our fine-tuned parameters. And then the bottom graph shows the untuned version when we were still kind of playing with our tuning parameters of our different controllers. And so from that you can see that in the top graph that we aren't experiencing any brownouts, and then also we are achieving relatively no or very little oscillations in our energy demand, which kind of shows that we're not producing an excess or consuming an excess of coal. So really like limiting that amount and being within the government regulations on that. And then from the bottom graph you can see that there's just a lot of oscillations, so it's really important to tune those parameters that are given in that table. And so just in conclusion, throughout this project we kind of just realized the importance of process control when you have such great wind fluctuation, or really any renewable energy source, because usually in those renewable energy sources have inherent fluctuation. You can't really always count on them. They're really like sporadic in nature. And then so when you couple that with fluctuations in non-peak and peak hours in your demand, you're going to have a really fine-tuned system, or else you're going to be wasting a lot of money, and really it's just not going to be an efficient system. And then also, in order for the battery to actually work properly, you also have to really tune those parameters well. What we were experiencing kind of in the beginning, middle stages of the project is the battery, it was taking some of that definitely taking the excess energy that was being produced and storing it, but it was never actually delivering storage back into the system. And it was just kind of, creating this huge, ever-expanding battery, which obviously, isn't feasible and really even inefficient, even if it was like a representative of a physical case. So we just determined that, if you're going to have these large integrated systems, which are going to be needed in the future with, the increasing regulations on fossil fuel production, and you're going to need these integrated systems with renewable energy, that you're really going to have to understand process control and understand how to tune the parameters so that your system works well.